Yeah.
There we go.
There we
Okay.
go.
Good. Okay. Welcome, everybody. This is, well, halfway through the last day of the Java Champions Conference. And here I have two of my favorite Java champions with me, Paul and what did you say your name was now? Gail, was it? Yeah. Gail Anderson. And yes, and they ran run Anderson Software Group. So it's like a unique power couple here. And what were we talking about today? It was FX?
JavaFX.
JavaFX, excellent. And yeah, so not sure what else to say. You have a nice introduction slide. So what I'll do is let you have the floor and get out of the way. And,
okay, great.
Have fun.
Thanks, Kirk.
Bye. See you in a bit.
Okay, hey everybody, welcome to the Java Champions Conference where we are virtual everywhere. My name is Paul Anderson.
And my name is Gail Anderson.
And we are with the Anderson Software Group. This is our session today, Say the Words Modern Java with JavaFX for Rich Client UIs. So who are we? Gail and I are the co-founders of the Anderson Software Group, a software training company here in the US. Our courses include Java, JavaFX, Python, Golang, modern C++, and Docker and Kubernetes. We are the authors of 9 textbooks on software programming and have 2 books on JavaFX that you see here. For our latest book, The Definitive Guide to Modern Java Clients with JavaFX 17, we contributed a chapter on JavaFX fundamentals, as well as a chapter on packaging options for JavaFX executables. And our other book is JavaFX Rich Client Programming on the NetBeans platform. Gail and I are also Java Champions and Oracle ACE members. Okay, here's our agenda for today's session. We're going to begin with a discussion about why you might want to use JavaFX for your UI on mobile devices. And then we will present an architectural overview of using JavaFX in the mobile space. And we'll also discuss and show you some really cool tools you can use, like Glue on Substrate and Graal VM to create native images. And all of these features will help you design your mobile applications. And then how do you get started? Well, there's a convenient Maven plugin from Gluon that helps you build native execution apps for desktop and mobile, and we'll show you a convenient starter page. We also have 2 different mobile apps that we're going to demo for you today. The first one is called Tilt Maze, and it is in the app stores. It uses the device's accelerometer, and it's a really nice demo for showing you how to access a hardware sensor in a device-agnostic way. The other demo that we have is called Wordish, and this is based on the popular Wordle game that is in the New York Times, and probably a lot of you are playing the game. So we have it running on the mobile devices. And one of the things that's really great about Wordish is that it shows off the various JavaFX features that we'd like to show you today. Things like advanced CSS styling, high-level animation, charts, and using and customizing a tool called Scene Builder. We'll also got introduced to you a lot of JavaFX techniques that we used. And we'll be leveraging that in our Wordish application. And then at the end, we'll summarize the session and what we talked about, and then we'll take questions from everybody. Okay, so why JavaFX on mobile? Well, a critical goal here is to write platform-independent source code, write once and install everywhere. So what we did was the design approach is using the Gluon tools that we're going to discuss, and then the Oracle VM platform, which allows you to build native images from your Java code. With JavaFX, you should know that it's a mature and well-maintained UI toolkit. It's platform independent, and there are really good client tools from Gluon and the Graal VM JDK to help you build your native images. The targets are extensive. You can target iOS, Android, Mac, Linux, Windows, embedded, and Mac with the Apple M1 chip. And finally, JavaFX has a rich set of UI controls, a library for various charts, and JavaFX also includes a scene graph metaphor to manipulate the nodes that you have in your program, and then to separate the model from the controller, we have a markup language called FXML that we use. And you can also use the JavaFX concurrency library to support asynchronous background execution, which is important to keep your UI responsive. JavaFX also has observable properties. You can write listeners and event handlers, and it supports binding and to maintain your program state. Now remember, JavaFX is Java APIs. That means that you can use streams, lambdas, and all the new modern Java features, such as records and the enhanced switch syntax. JavaFX is maintained by Gluon in partnership with Oracle, and Gluon has commercial support with long-term LTS releases. Okay, here is a diagram from Gluon's website. Here you see the pieces that you need to build a modern JavaFX application. First, in the middle, you see the Gluon substrate, which is a framework that leverages GraalVM native images, JavaFX modules, and support libraries. At the bottom, you see the GraalVM JDK, and this, like I said, converts JavaFX applications into native executables. These tools help bundle all the required supporting native libraries for your target system, and a Maven plugin allows you to perform all this magic in a pom.xml file. Now, once again, the GraalVM toolkit is from Oracle, and it helps you build standalone native executables or a native shared library. A native application does not need a Java virtual machine, a JVM at runtime, and that means users don't have to install a JVM as a separate step. You can use the GraalVM AOT ahead of time compiler, and the native image is specific to each operating system and machine architecture. Furthermore, the memory footprint is smaller and startup time is quicker than typical JVM type applications. And the native images apps can run on iOS devices, which we all know prohibit JVM applications. Okay, so at this point, I'm going to turn it over to Gail, and she's going to show you our two demos today that we'll be discussing.
Okay, hi everyone. The first program that I would like to discuss with you is, excuse me, Tilt Maze, and it is what we wrote it last year, and it's a proof of concept application. It is available for you to play around with. It's on the Google Play Store as well as the Apple App Store. It runs the same source code, runs on both the iOS device and Android devices. And it features accessing the underlying hardware in a device agnostic way. So Tilt Maze is a simple game that lets you control the flow of a ball through a maze without falling into these holes, and to get to one of the two green end holes. And you do that by simply tilting the phone, and the program reads the accelerometer in an animation loop to then control the ball. We use Gluon Mobile for mobile-friendly controls. We use FXML, as Paul indicated. FXML is a markup language that describes our view, and by using FXML, we keep the view and controller separate, and we can also use Scene Builder to design the view. We use collision detection and property binding. So let's go ahead and look at this in the IDE. We're using IntelliJ here, and the first thing I'm going to do is run it. Now, you might be thinking at this moment, but wait, there's no accelerometer on typical desktops, and you would be right. Okay, well, I'm not sure what to do.
So, did you want to?
I want them both at the same time, and I'm not sure if I can do that with. Yeah, it won't let me. Okay, I'll figure this out in a minute. So we're going to show you the game. Excuse the bad background. So here we click the start button, and then we mimic an accelerometer simply by reading the, there we go. Okay, so if we go into a hole, oh my God, we lose. Let's see if we can actually get it into the green hole. Yeah, just go to the green hole.
Oh, try it again. You know,
It's harder.
Yeah.
Okay, okay, well, this is the last time. If it doesn't work, it doesn't work. It's actually much harder on the phone because accelerometer is very sensitive, but as you can see, it's kind of hard here. What we want to show you with this is the mobile-friendly controls, the start button, the slider, which controls both the timing and the difficulty. The more expert, the less time, the faster the ball rolls. And this is a kind of combined control that includes a progress indicator with a label that does the countdown to act as a timer. Okay, let's... Okay, and this is our tilt maze running in the IDE. So let's go back to. Oh, I know what I want to do. I want to take this out of. How do I take this out of? Okay, we'll go back to the notes. But I need to take the. Okay, so Tilt Maze is the first program we want to show you. The second one is called Wordish. And if it looks kind of familiar, it should, if you are familiar with the New York Times Wordle. And as I became a fan of Wordle, and as I was playing it, I said, oh, this would be a great program to implement in JavaFX because of the animation, the kind of unique styling of the tiles, the virtual keyboard. And so, and there was a lot of cool JavaFX features that we were able to use to do this. So this is one I want to show you next. And I want to take this out of. Okay, I need
go up to the top and take it down that way.
Yeah. Okay, so.
Yeah.
There we go. Okay, sorry about that. We should be able to, we should be okay now. Okay, so let's go ahead and run this. All right, this is more like it. Okay, so here you see the program running, and we use a specific material design customized third-party library for the fonts. Here's the rewind button, the information button that tells you how to play, the stats button that keeps track of how your games are. We haven't played any yet, and the virtual keyboard. So let's go ahead and input a word, and we use this high-level animation to do what I call the reveal. And nice about running this in the IDE is that we can cheat, and that's great for demos because I can show you what it looks like when you win. Now, this game is a little different than the Wordle. For one thing, you can play it over and over and over, and it doesn't have a curated list of answers. So the target word is simply random, but it comes from the list of all allowable words. So it's a lot harder. So like autumn, I actually
what is that word?
Don't know what that word means. Okay, so we'll talk more in details about the different JavaFX we've used for this. So let's go back to the notes a moment. Okay, so nice. You've shown us 2 example programs, JavaFX, but let's say I want to write my own JavaFX program. How do I get started? So this page, which by the way, these notes are available for you to download right now if you like from our website. This page has a list of resources that you can access to get you started. And the first one I want to show you is, oops, nope, is the Gluon start page. Gluon.start.io, and here you can define a starter application. So you can define your JavaFX version you want. We usually use the latest, but you could use the early access release or previous LTS or stable releases. You can choose or not choose Gluon features. The Glisten is the very mobile-friendly controls platform and we use that for Tilt Maze. We did not use it for Wordish. Glisten Afterburner is a minimalist dependency injection that's very convenient to use. Connect lets you load data, outside data resources. Maps is a map library. CloudLink lets you connect with your application to the enterprise in a very nice way. And then the attach framework is how, for example, you access your device in a device agnostic way. So here are several, there's tons of things that you can use, but it gives you the minimal things. But for example, in Tilt Maze, we clicked the accelerometer. So it gave us the accelerometer library. And when you think you've configured it how you want to, you can look at the project. And this is nice. The README file gives you all the commands, Maven commands you need to either produce a desktop JVM or the native image builds that you get from running the Graal VM. It also lists the JavaFX modules, and we said Java 19, so these are our JavaFX modules that we use, and it gives you the Gluon features as well. Okay, so once you've done that, then you can click on Generate Project, and it will download a zip file to your development machine, and you can then open up the Maven project in your favorite IDE. So let's go back to the...
Now you want to go to the Graal VM.
Okay, so I was going to go there. Okay, yeah. So the second link I show on the resources page is a link to the Graal VM download, and you will use this specific Gluon version of Graal VM, and you can see that there's different versions depending on whether you're using Java 11, Java 17, whether you're using Windows, Linux, or Apple, or the Apple M1. So when you download that and then set your Graal VM home environment variable to point to that, and then Gluon takes care of the rest. Another link that I find very, very useful is a GitHub link that goes to Gluon samples, and they have maintained this over the years as JavaFX has developed and been maintained. And what I recommend is that you go ahead and just download the whole thing, unzip it, and you can study these projects. They're basic Hello FX projects using FXML, using the Gluon mobile framework, maps, Raspberry Pi, and then those are really basic applications. And then there's other sample applications that are more involved. 50 states and notes are a couple that I've looked at, and it's a great way to learn how other people put together a JavaFX application. And the final link on this page is, yes, we're going to show a little bit about JavaFX to get you interested, but we're not going to go through the detailed step-by-step. It would be more than an hour talk of how you get an application from an idea to the app stores. And so last year I wrote a 3-part article that explains that. The first part, and I use Tilt Maze as an example, the first part shows the JavaFX we use to create the application. The second part shows what you need to create the native image for Apple as well as Android. And there's some development tools that you need to get and make sure are in place to do that. And the third is the steps that you need to put this application in the 2 stores. So hope you find this interesting and useful for you to use. Okay, let's go back to the notes. Okay.
Yeah, and that the previous slide that you all saw has those links that Gail went through and showed you.
Yeah.
Yeah, here they are. So, and this again, the PDF is up on our website, so you'll be able to go find those very easily just by clicking on them. Okay, so when you do a JavaFX application, the way you want to start is you want to separate your view from your model and controller. And the way to do that is to use a markup language called FXML. Okay, and you can it's a declarative layout, and you could do it yourself. But what's really nice is that Gluon has a tool called Scene Builder, which allows you to drag and drop components from palettes and things, and it generates the FXML code for you. This is really, really nice because you can get your UI up and running very, very quickly, and you can move things around, and the FXML is generated for you. And this will save you a lot of development time, because if you didn't use this approach with FXML and Scene Builder, then you would have to write Java code to instantiate the controls and call setters to configure them. So you're going to end up writing a lot less Java code if you take this approach. The other nice thing about Scene Builder is that it allows you to customize your own controls, and you can even add your own font libraries. Now in Wordish, the major layout controls that we use is a grid pane for the button controls and title, a tile pane for the letter labels, and a flow pane for the virtual keyboard that Gail had shown you. So what we're going to do now is Gail's going to go back and show you Scene Builder and how cool it is to design your UIs with.
Okay, so our main view is in a file called wordish.fxml, and as we indicated, FXML is a XML-based markup language, and it would be quite tedious to modify it in an editor, although you can. If you just noticed there was one simple thing you needed to change, you could just edit it in the text file. But it's more convenient and nicer to design your view using Scene Builder, and there's a couple ways to get there from IntelliJ, and as well as the other IDEs as well. So you could go to the Scene Builder tab. That brings up Scene Builder in this frame. But if you want a little bit more real estate, you can bring up Scene Builder as an external program by going to the drop down and clicking on Scene Builder there. And it's going to come up, and you can see it looks a lot like our program. So as Paul indicated, it's designed as a vertical based layout. So we have 3 major layout components that we use. The grid pane at the top, which is a simple 3x2 grid. We put the buttons spaced out at the top, and then the title spans the second row. And you can go over here to the right, and you can change the properties in the inspector. So it's really nice to visually work with. The second area we had is a tile pane, and a tile pane expects the rows and columns to be aligned, and the cells are all the same size, and that was perfect for our letter label contents. Now, letter label is actually a customized class that we use to extend label, and we added a couple properties, and you can see the properties here. And these properties maintain the state of the tile while you're playing the game. So if it's matching, it becomes this green color, and if it's partial matching, it becomes this gold color, and if it's not matching, it becomes this gray color, etc. And then the plane, and then there's the display. Similarly, we have a a flow pane down below for the virtual keyboard, because now the columns are not aligned and we want it to look more like a keyboard, and also the cells are not all the same size. The enter button and the delete button are a little bit larger, but these are buttons, but we extend buttons. They're called key buttons, so we can have, again, we added a letter, a property. So it's the same sort of thing where we display the state of this particular key while you're playing the game. Now, one thing to note is that if you just brought up Wordish in a standard scene builder, it wouldn't work right, because scene builder doesn't know about key buttons, letter labels, and also this Iconly font library that we use to customize our buttons here, and also the delete key. So we had to tell scene builder what these classes and font libraries look like, and you can do that. We compiled our classes into a jar file, just the classes that we were using, and installed that in Scene Builder, and as well as we gave the repository markings for the Iconly font library, so it could go out and grab the Iconly font library. And then once you install them in Scene Builder, they show up here under the custom tab, so you can go ahead and click them, drag and drop, and click the various icons to put in your buttons or however you want to use it. Okay, so that's just a very basic overview of Scene Builder, how you might want to customize it and use it to design your application. So we're going to leave Scene Builder now, and we're not going to save any of these things, and we're going to go back to the notes.
Okay, so one of the really nice features of JavaFX is property binding. And when you're designing UIs with traditional toolkits, you have to write a lot of listeners and have callbacks when users are interacting with your UI. But JavaFX has a property binding mechanism, which means that you take a Java field and you wrap it into an observable property so that when that field changes, someone else that's binding to that property can be notified. It's a very, very succinct and a nice feature in JavaFX. So what we do in Wordish is we have property binding to maintain the game state when a property values change or they're being set. And the binding APIs let you build complex expressions that define the state of your properties. Property binding is much better than writing listeners. It's very succinct, less error prone, and it's really nice to use. In the JavaFX APIs, there is a large set of logical expressions that you can use, and here's just what they look like. And when you write your Java code, you use the builder pattern, consecutive dots with these calls. So it's very, very readable and very, very easy to do. So Gil's going to show you some examples now of property binding in the Wordish application.
Okay, so excuse me while I go to the right place in our controller. Get rid of this guy and bring up this. So, okay, so you can see the bind here. We use the bind extensively to control whether or not certain buttons are enabled or disabled while you're playing the game. So, for example, the stats button, which is this button, and the info button are basically enabled, except while you're playing the game, they're disabled. And that's what this binding expression does. So let's go and restart the game, and you can see that they are now disabled. Let's put in a word. Okay, then we have 3 more buttons that we also controlled the disable property with using binding expressions. The enter button, which is down here, the delete button, also at the bottom, and all of the buttons in the virtual keyboard, which are key letter buttons. So first, the enter button, if you think about it, you want it disabled if you haven't filled the row with words, and if the game is, if you're not in the middle of doing the game. So right now it is disabled. We can't, I'm hitting the enter button, nothing happens. However, I'm starting to put in some words. It's still disabled because we haven't filled up the row yet. And as soon as I fill up the row, then boom, it's enabled and I can do it. So that's what this is. Similarly, the delete button, it has its parameters are a little different because the delete button doesn't make sense if your your game is and if your session is over, that word submission is over, or if there's nothing to delete. So for right now, it is, there's nothing to delete. So the square num is 0. So we can start putting in words and letters, and then the delete button works. But then when there's nothing there, then it stops working because it doesn't make sense. And similarly with the virtual keyboard, if the row is filled, we don't want any more letters. If the game is over, it doesn't make sense. Or if we're in the middle of processing the word, it doesn't make sense. So we can't do any more. Oh, yes, we can do more because it's the next one. Okay, so as you can see, if you didn't use the binding, then you'd have to write listeners to know what the state of these various things are. Also, you notice that these two buttons have the disable property behaves exactly the same. So you could, once you've set the stats button, for example, the info button could bind to the stats button instead of this. If you determine that they always behave the same, then you could do that if you wanted to. Okay, so that is binding. Let's go back to the notes.
Okay, so another neat feature that we used in Wordish is something in JavaFX called pseudo classes. A pseudo class is an under-the-hood feature that is used throughout the JavaFX system. And specifically, a pseudo class is a way to specify the CSS styling of a control based on its state. For example, you could disable a button in your code by setting the disable property to true. Then your button becomes less opaque. And the CSS pseudo classes are applied when the property updates. In Wordish, we have two classes, a letter label and key button, that manipulate and work with a property called letter display. And then we have a separate style.css file that defines the styling for the various states. So the pseudo classes made the styling very, very nice to work with. And Gail's going to show you a little bit about that right now.
Okay, let's go to the IDE, and we're going to bring up and let's bring up the program. Okay, so remember that I said that these specialized classes, the letter key and the key button, have additional properties. And one of the properties for letter label, for example, is called the letter display property. And this is an example here where we're simply setting it. But when we set it here, what happens is that the letter display takes on the color according to its state. So we don't have code in this Wordish controller.java class that actually manipulates the CSS in the Java code. I mean, there's ways that you can do that, but that tends to be a bad practice and it makes your code very brittle. Instead, we're using pseudo classes. And as Paul indicated, pseudo classes are used under the hood. I call it scaffolding code throughout the JavaFX ecosystem. And one of the really common things that you've seen already is the disable property of buttons uses a pseudo class that says when you set the disable property, it makes it less opaque. As you see this I and the charts button, it's very faded out. Whereas this redo the game is enabled. And that is done with pseudo classes. So there's no code in there that says make this less opaque. You simply say make disabled property is true. Okay, so how do pseudo classes work? So first of all, our letter label is, as I said before, it extends label. And we've added a couple properties with it, both match result and letter display. And letter display is the one that uses the pseudo classes. And because letter display is a JavaFX property, it is observable, and you can, if you want, override the invalidated method to then update the underlying scaffolding code, the pseudo classes for that property. And that's what we do. So, and this is the enhanced switch statement. And we turn off all the pseudo classes, and then we set the one that comes in that we've changed it to the correct pseudo class. And we use this pseudo class here, letter style. And you can see that pseudo class is a JavaFX CSS class. And this is where we define the CSS that we want applied when the particular state that we're setting matches it. So now let's go to our CSS class, and you can see the different matching, no match, partial match. This is where we define what the color, the fill, and the border look like. And these are all colors that we defined throughout our application, so we get that consistency. And notice that the IDE tells you what these colors look like. But you can notice that by separating the CSS from the state, you can change what, for example, what matching color is by simply changing this, and then the change will propagate down below to the CSS class and to the property. So if we want to make matching to be some bright pink, for example, we could do that. Okay, so that's a real general overview of pseudo classes and their power. Let's go back to the notes.
Okay, another really cool feature of JavaFX is the ability to do animations. Now, you have some choices when you do this. You can work with a low-level API called keyframes, where you really can control any kind of animation that you want. But a very nice part of the library is the animation APIs, which are above higher level abstraction, above the keyframes. They're really easy to use, and they're really easy to set up, and they're very configurable. And what, of course, animation is doing is it's operating on the nodes in your scene graph, because JavaFX works with a scene graph, and that's what happens there. So here are some of the node animation transitions. Translate transition will move a node. Fade transition will change the opacity of a node. Rotate transition will rotate a node in some way. And then if you have multiple transitions, you can run them all at the same time in parallel with parallel transition. And if you have multiple transitions, you can run them sequentially one at a time with sequential transition. And this, this worked out really well in Wordish, and we were able to do a lot of the animation that you see. And Gail's going to show you some examples of that right now.
Okay, let's bring up. Get to the right place. Okay, so we have three basic animations we use in Wordish, and some of them use parallel transitions, which means they happen at the same time, and some of them use sequential. So one thing that we haven't showed you yet is the transition, the animation that happens when you input a word that's not, quote, legal, or it's not in the dictionary of allowable words. So Paul has said, hey, I bet Fritz is not in there. And you know what? He was right. So you can see that this animation, it's kind of like a vibration. Oh, you did something bad, but vibrates back and forth. Okay, so how do we do that? Animate bad word. We create a parallel transition because the vibration happens at the same time. And the argument is the list of tiles that we're dealing with, just this row, these 5 tiles. So for each one of these, we create a translate transition. And remember that moves it. The transition should last 100 milliseconds. We move it in the X direction, which means horizontally by 20 pixels. Positive moves to the right, negative to the left. We set auto reverse to true, so it goes back to the starting point, and the cycle counts 6. That means goes back and forth 3 times. And we put this translate transition into our parallel transition. We do that for each one. And when we built them all, then we play it. So again, that's very simple. Okay, so the next one I want to show you is called the animate label group, which is what I call the reveal. Let's okay, let's get something that is a word. So the reveal happens. This one is a little bit more complicated because what we do is we rotate the tile down 180 degrees. And if we did that, the letter would be upside down and backwards. And we don't want to show the upside down backwards. And I was trying to mimic what Wordle does. And so I combined a fade with a rotate in a parallel transition. And then I did that for each one of them. And at the end, you get the reveal, the end of the individual tile. So let's hit return. Okay, and then let's see. No, that's what it was. Again, I have to. Okay, well, we'll show you what the, okay. So that's the reveal. So we do the fade and the rotate together, and it turns it upside down. So you get the look of something flopping down to give you the reveal. Okay, so let's look at what happens when you get there's a final one, an animate success group, which is what I call the happy dance. Let's show you that one. And okay, so what's going to happen here is first you're going to see the reveal, and then you're going to see each individual tile kind of rotate back and forth in this celebration. So when I hit return, you'll see the reveal, which is the animate label group, and then you'll see the animate success group. There's the reveal, and there's the success. Okay, so what happens with this is that it happens one at a time, so that's sequential. And for each one, we rotate it in the z-axis by 60 degrees, set auto reverse true, and cycle count to 4, so it goes back and forth twice. And then we play when we have it all set up. Okay, and JavaFX is great for these high-level node animations. So anything that's a node, you can rotate. So for example, I could rotate the entire panel. I can apply animations at any level that's a node. And remember, scene graph is a tree of nodes. So you can rotate at whatever level you want. And this is decidedly different than for people who want to create individual shooter type games where the animation needs to be at a lower level. And there is an FXGL game library, game engine, I would say, that you can use to do that. And that's a different sort of animation, but this high level animation works really well in many, many situations.
And it's fun to write the code and make it work too. Okay, the JavaFX library also gives you charts, and we applied those charts that we had to the Wordish application as well. So with the charts, we were able to track our guesses in Wordish, and here we use a horizontal bar chart where the users can see their game statistics during play. So the bar chart icon that you saw in Wordish will take you to a separate statistics view, and we use a separate FXML file for this layout. What we do is we collect the game statistics in a singleton object, and then we display the number of games that were played, win percentages, the current streak, and the maximum streak. And below the statistics data, we display the distribution horizontal bar chart. So Gail's going to show you how to add data to the bar chart, how to customize it, and a few other topics here as well.
Okay, so let's bring up the game first and show you what it looks like. Okay, it's a good time to go to the stat page. We've played a couple games, 2 games. The most recent one had 5 guesses. The most recent one is green. So the stats page, this is pretty much the same as the Wordle on the New York Times. We play the games played, the win percentage, the current streak, the max streak. And then we use a standard JavaFX bar chart to display the stats. And we had to customize the bar chart a little bit to make it look like the New York Wordle bar chart. So let's show, for example, typically people see bar charts oriented the other way, where the bars grow up from the x-axis. And here we have the bars growing horizontally out from the y-axis. Also, we put the 1 at the top and the 6 at the bottom. Again, that's how Wordle does it. So we had to, when we added the data, we had to add it to the beginning of the data set to get the order correct. Okay, so let's look at some of the code. Okay, so this is a standard JavaFX bar chart, and this is how you decide how it's oriented, or how you specify how you want it oriented by the generic parameters in the bar chart. So when the first parameter is a number and the second a string, you'll get what you see here. If it's the other way around, where the first one is a string, the second is a number, you'll get the vertical bar chart where the bars grow up. So then we are just consistent when our series and our data sets match this. Now, the JavaFX charts is a very flexible system, and because of that, it can be kind of complicated to use. For example, you have multiple series in the charts. In this case, we just needed one series. There's just one set of data that we're displaying. So let's go to, so this is, for example, how we add the data to the bar chart. We're looking at a singleton data that we, piece of information that we pass in, and we have the series, we have the data, and then we add it. And this is, we're adding it to the beginning of the bar chart data. And we add the series to the bar chart data series. And again, there's just one series. But you see that the number string is consistent because that's how we defined the bar chart. We also, we know that we customized it a little bit. So we put in some, the fill to make the background color the same. And then the one tricky thing that we did was that we actually, these are labels that we added to the bar chart. And a chart is just like anything else, part of the scene graph. So if we can find out where the bar chart is when it's finished rendering, we want to put the label at the end of the bar. And this isn't a consistent place, because depending on what your data looks like will depend on the configuration of the bar. So for example, if we had another bar that was, for example, instead of 1, if it was 5, it would go out to the end, and these 1s would shrink down. And so it's not a consistent calculation. So you have to say, where's the end of the bar chart? And you can't do that until after the bar chart is completely rendered. And it's not easy to find out when it's completely rendered. So, oops. So one thing we did was we just put a little delay in, and this fixed labels goes out and says, okay, where's the end of the bar chart? And I have to put the numbers in there. If that doesn't sit well with you, there's another way that you can do it, and is you can create a writable image, and with the snapshot. And when that finishes, you know that your chart has been completely rendered. So at that point, you can also go in and find out the end of the bar charts. So that's our little overview of using charts with Wordish.
Okay, so let's summarize what we went through here in our session today. We hope that all of you see that JavaFX is a very viable coding platform for creating mobile apps, and that you can add to both the Google Play and Apple App Stores. Java and JavaFX code base, a single code base is being used for both iOS and Android, and that's very, very convenient. And then we talked about the tools that you could use from Gluon and the Graal VM as well.
Oh, and I wanted to interrupt Paul. I don't know if I made it clear. So Tilt Maze is available in the app stores for you. Wordish, we haven't put them in the app stores, but we give you the link for the code. For GitHub, so you can play around with it. We put Wordish on both the iPhone and the Android locally for testing, but we haven't put it in the App Store yet. So in the 3-part description for the Fujay article, we've done parts 1 and 2, but not 3. Go ahead.
Okay. Yeah, so what the demos that we did here, Tilt Maze and Wordish show different features of JavaFX. In Tilt Maze, we emphasize the device-agnostic access to hardware-level sensors and Gluon's mobile framework. And in Wordish, we showed how to customize Scene Builder, how to do advanced CSS styling with pseudo classes, and node-level animation, and the use of JavaFX charts. Both of the apps that we showed you today leverage Gluon Substrate and the Graal VM toolkit, so that you can build native execution images that target iOS and Android, as well as on the desktop. Now remember, with JavaFX, you have a mature coding system. JavaFX is Java and includes the modern language with all of its neat features. And the demo applications that we showed different aspects of JavaFX. So what mobile options then do you think you might build? Well, we can find out. Okay. I want to thank everybody for attending. Here are our email addresses and Twitter handles. The source code for the demos that we showed you today are available up on GitHub. And this is also our current book, The Definitive Guide to Modern Java Clients with JavaFX 17. And the PDF that we use to do our session is available on our website. Oh, maybe you want to go to our website real quick so we can show them that.
Oh.
Yeah. Oh, you can't. Okay. Yeah, go to the. Yeah, just put in. And our website is asgteach.com.
Yeah.
Okay, and the slide deck there is available there to download, and of course, our session is going to be available for other people to watch as well. Okay, hey Kirk, good to see you again.
Yeah, sorry, I had a audio problem on this end. we got to
Ah,
sort out or whatever. Excellent. Wow. Okay, so that's quite the presentation and 2 fun games actually. I like the physical version of the Tilto thing. I don't know if you have one of those around.
yeah, the tilt maze.
We have
is
one
really,
of those too.
The tilt maze is really pretty challenging because the accelerometer is really sensitive.
Yeah.
So you have to move it in your hand, and you want to start off with in slow mode, and then as you get better, you can speed it up. But it's pretty fun. It's pretty addictive too. The people that we've had them use it say, "Geez, my kids love it." So.
Well, here's a silly question for you, and have you tried playing the Tilto game while driving around in the car? Or finding like the windy roads and just see what the accelerometer is doing, like, because you
mean the passenger? Oh yeah, it would. That's
well, of course, passenger. Yeah, sorry.
that no, I mean that it would probably just go off the. It would go off. It wouldn't go off because it does collision detection, so it'd keep it in the thing. But it would be interesting to see what that looked like.
Yeah, I
didn't test it in that mode.
Yeah, and when I was a kid, I had the actual box, with the knobs on the side, the wooden box with the knobs on the side, and then you had the ball, and then you had to tilt the thing to get it around. I spent hours doing all that, so we caught the idea. Hey, we can put that on the phone and use the accelerometer. And then, of course, when the guy did the Wordle game, we said, hey, we can do that too, because there's some cool animation and all that. So, these games are a good way to show people, how powerful JavaFX is and how easy it is to use a Java code base to get these mobile apps up and running.
So the question is interesting, is like you deploy this on the App Store and everything like that. I'm just, well, let me step back and say, how difficult do you think it would be to get like the Tilto game working in a browser app as opposed to getting it into this like pseudo desktop app environment? And I'm just, that's one question I think is leading into the next question is like, where do you see desktop apps going in the future? Are we now just going to stuff everything into a browser and we're going to have one desktop?
No, I don't think we'll ever do that across the board. The browser will always be, people will want to use the browser because they think of it as being very portable. But there's development that allows you to run JavaFX programs in the browser.
Yep.
I haven't worked with that myself, but there's a JFX Central, which is a website that talks about all things JavaFX, and that website is done completely in JavaFX. But the desktop JavaFX has always been very prevalent in companies and government applications that are specifically not the browser for security reasons, and I think that will continue to be the case.
Yeah, I agree.
So it's a good source. It's a good way to do desktop applications in that way.
Yeah, but we'll see how this project goes when putting JavaFX in the browser. There's a lot of issues and a lot of problems to solve, but we'll see how, and that will change the game a bit too if that's successful, because then you'll be able to do a lot more interesting things in the browser.
Awesome. Well, guys, I think our time is up. Thank you for the wonderful presentation today, and thank you for everyone attending or spending their time watching this presentation. And I'm off to the App Store because I need some new games to play.
All right, great. Well, have fun, everybody. Have fun with this stuff because it is fun and it's really well done. That's what I like about it.
Excellent. Okay. Bye.
See you later.